So on page 5, you can highlight synthetic division, and I introduced it to you last week. What we're going to do is we're going to look at how, at the top of page 5 in example 2, this is the textbook one. They've done the long division, right? They wrote it in the right order. We have to remember in long division, we have to write things in the right order of degree. And they added the 0 for the x cubed because something was missing. Now we're going to find we can do this same question with something called synthetic division, and it looks like this. I'll do it right beside. Wow, that's a big check mark. That's kind of cool. So I make a box like this, and then I take the coefficients of my original answer, including the 0. So in front of the x to the 4 is a negative 4. Then there's 0x cubes, 2x squareds, negative 1x's, and a negative 3 at the end. Outside of this sort of square bracket or rectangle, I'm dividing by x minus 3, and I put the 3, but with an opposite sign. So if I'm divided by x minus 3, I put a positive 3. If I was dividing by x plus 3, I'd put a negative 3. And synthetic division works like this. There's some patterns we notice whenever we have just an x outside, and so synthetic division has a restriction. It will only work when you're dividing by x plus something or x minus something. Anytime you're dividing by something else, you would still need long division. So I'm dividing by x minus 3. I have my 3 outside. We notice a pattern that the first number here always matches with the first number there, right? In order to get a minus 4x to the 4, you'd have to multiply by a minus 4x cubed. So what we do in synthetic division to show that is we say, we just have to bring down the minus 4. Yes?
Why do you have the one inside with like minus 4 and minus 1, but the minus 3 is
Because, so the negative 1 goes with that negative x. So we're always taking the coefficient or the number in front of each of the things.
Oh, but that one.
And that one subtracts, so we need a negative to go with it.
But the x minus 3 doesn't.
The minus 3 still shows up as the minus 3.
No, I mean on the outside.
On the outside, this is always the opposite.
Oh.
So, and the reason it's the opposite, we'll see in the next step. So when we picked this 4 in long division, what happened is the 4 multiplied by the x to get minus 4, and that went away, because obviously we wanted to subtract. And then the 4 also got multiplied by the negative 3 to get a 12. We're going to do the same thing, that 4 by negative 3, but this time we have a 3 here. 3 times negative 4 is negative 12. So we take this 3, multiply it by that negative 4, and get negative 12. And what synthetic division does, and the reason we change that 3 to the opposite side, is it allows us to add instead of subtracting. In long division, you had to subtract, and the number one, if you ask teachers, where is the number one mental math error that students make in long division, is they forget how to subtract. They make lots of subtracting errors. You make less errors when you add, and so 0 plus a negative 12 gives me negative 12. And now I repeat this process just the same way that I repeated processes in long division. I'm going to take this positive 3 and now multiply it by that negative 12 to get negative 36. And when I add them, I get negative 34. Notice that matches up with the negative 34 in our long division. Again, one more time, I multiply this negative 3 by that negative 34, I get negative, the 3 by the negative 4, I get negative 102. Add those up again. Oh, I wrote it in the wrong spot. That's why these columns are important. Negative 102, add that to the negative 101, and I get negative 103. And again, that matches up. And one last time, I multiply the 3 by the negative 103 and get negative 309. Add that up, and I have a remainder of negative 312. And so the synthetic division gets us all of the same numbers. It gets us the negative 4, the negative 12, the negative 34, the negative 103, and the remainder of negative 312, but we have to write a lot less. So it's sort of a shortcut method that way. Yeah.
When you say added up every single time, is it with the 3 or is it with the
So
numbers that are?
we're adding, so this column right here, what is 2 plus negative 36? That's what I'm adding.
Oh, so you're timing the 3.
Timesing the 3 by the negative 12 to get the negative 36, and then I add the column to get negative 34. So we'll go to example 3 and work through this again. So we've set up our box. This is already in descending order, which is good. There's no degree that's missing, so we don't have to add any zeros. So we're always doing our preliminary check. Are things in the right order? Is anything missing? And then we write our coefficients out, 2, 3, negative 4, and 5. Our number out in front, since we're dividing by x plus 2, we do the opposite sign out in front and do a minus 2. First number, we always just bring straight down. And from here, to get the next number, we multiply the negative 2 times the negative 3. So negative 2 times negative 3 is positive 6. And then you add in your column 2 plus 6, 8. That's easy, right? Not bad at all. Now we just repeat that process. Now I have the 8. That 8 gets multiplied by the negative 2, negative 16. Then I add my column, negative 13. And we just keep repeating this process. Now with my negative 13, I multiply by the negative 2, giving me positive 26, and I add positive 22. And finally, negative 2 times positive 22, negative 44, and I add negative 39. So my division statement. And remember the shortcut that we like for our division statement? Put the polynomial in brackets, and above it say, let p of x equal. So then in my division statement, I don't have to rewrite all of that. I can just say p of x equals, my divisor is x plus 2. My quotient is going to be negative 3x cubed plus 8x squared minus 13x plus 22. And the remainder, so this part here, my remainder, this is my quotient, this is my divisor. This one here is always my remainder. Some things that can help you write out your quotient, because now your quotient just has numbers, right? This x cubed will always be, if you're using synthetic division, 1 less than the power that you started with, because you took out an x, right? The divisor has an x, so this one has to be 1 less in the degree, because you're multiplying that out after what you would still need to get an x to the 4 to start with. So there's our division statement, and life is easy. I'm going to get you to do circle questions 8, 9, 10, no, 8, 9, 11, and 12.